All right, everyone. So we just finished number one. So I'm going to go ahead and erase my work for number one. And what I'm going to do now is I'm going to go ahead and bring up number two to the top and move number three down here. And we will continue with number three later. And right now we are going to work on number two. So again, I'm going to write my RAP table over here to the right hand side, my wrap table. And what I'm going to do again is I'm going to count, I'm going to write down the atoms. So I'm going to have carbon, that's one of my atoms. Hydrogen is one of my atoms. And oxygen is one of my atoms. And then I see hydrogen's repeated and oxygen's repeated. So I have all my atoms listed. And then again on the right hand side, I have carbon, oxygen, and hydrogen. But they're all repeated and they're all listed here. So let me go ahead and take away some of my marks because I want to make this as simple to understand as possible. Now what I'm going to do is I'm going to go ahead and list how many on the left hand side do I have. So I've got 2 carbons. I've got 5, so I'm going to do this in a different color. I've got 5 hydrogens here, 1 hydrogen there. So that's a total of 6 hydrogens, so we'll put hydrogen in purple. And then maybe we'll put oxygen in green. We've got 1 oxygen there and 2 oxygens there, so that's a total of 3 oxygens. Okay? And then I'm going to do the same thing on the right-hand side. I've got 1 carbon. I have 2 hydrogens. And if I look at my oxygens, I've got 1, 2, 3 oxygens. And so the reason that the RAP or the wrap table is so helpful is because it helps me to see, okay, well, the oxygens are good. I don't even need to worry about the oxygens. And so what I can do is I can either start with carbon or with hydrogen. And so what I generally like to do is I generally, when I'm doing a combustion type problem, what I like to do is start with carbon because that's the one that I think is the easiest to balance first. So that's what I'm going to do. So I'll start with red, and I see that the carbons are off balanced. I see that there's 2 on the left, but 3 on the right. And so what I'm going to, 2 on the left and 1 on the right. So in order to fix that, I'm going to put a 2 out in front. And when I do that, that's going to change the carbons to a 2. It's also, if I keep my color coding correct, it's going to change the oxygens to a 4. But there's also an action over here, so that's going to be actually a 5. Now, you might say, well, I just created another problem for myself. So what I want you to think is, let's not worry about the oxygens. Let's just not worry about them. We will do the oxygens at the end, okay? So now let's go ahead and work on the hydrogens. So I'm going to do that in purple. And so we see on the left I have 6 hydrogens. On the right I need 6. So it would make sense to put a 3 out in front here. And that would change the hydrogens to a 6, right? Because 3 times 2 is 6. But it's also going to change the oxygens to a 3. But remember, I also have 4 oxygens over here. So it's actually going to change my oxygens to a 7. Because I've got 3 oxygens here. But I've got 2 times 2, which is 4. And 4 plus 3 equals 7. So now I see that my carbons and my hydrogens are fixed, but I have an issue here with my oxygens. So what I'm going to do is I'm going to go ahead and erase this number so that I have a little bit more space. And so the problem here is this. Now I have to go back and I have to fix the oxygens. However, if I put a number out in front over here, it's going to mess up my carbons and my hydrogens. And if I put a number out in front here, even if I put something like 3, I can get 6 out of this. If I put something like 4, I can get 8 out of this, but I can't get an odd number of 7. So the problem is that there's no way that I can go about this problem without putting a 2 here. I have to do that. And that's going to be frustrating because then that means I have to change everything again. But that's just the nature of balancing chemical equations. So what I'm going to do is just erase some of my circling here. And I'm going to have to go back. And I'm going to, again, I want to save the oxygens, I want to save this for the end. Okay, I'm going to do the oxygens at the end. I'm going to go back now and fix the carbons. So let me go back and fix the carbons. And then after that, I'm going to fix the hydrogens. So let me go back and do that now. When I put this 2 out in front, it changes this carbons to 4. It also changes the hydrogens. Remember, there's 2 sets of hydrogens. That's a total of 6. 6 times 2 is 12. So it changes the hydrogens to 12. It also changes the oxygens to 2 plus 2, which is going to give me 4 on the left-hand side. So now what I'm going to do is try to fix my carbons by putting a, actually I'll need to put a 4 out in front. And when I do that, that affects my carbons because that changes them to a 4. And it also affects my oxygens, so that's going to change my oxygens to an 8. But then this oxygen up here is going to become a 9 in total on the right-hand side. Now remember, we're saving the oxygens until the end. So now that my carbons are fixed, I want to come to my hydrogens, and I have 12 on the left-hand side, so I want to get 12 on the right-hand side. So I'll use purple again, and I'm going to put a 6 out in front. And so that will give me 12 hydrogens on the right-hand side. And then it affects my oxygens, because that'll be 6 oxygens right here, plus the 8 oxygens over here. So that's actually going to change my oxygens on the right-hand side to 8 plus 6, which gives me 14. So now I have 14 oxygens on the right-hand side. So now I come to this last bit of oxygen. So my hydrogens are fixed, my carbons are fixed, and I just have to come back and fix these oxygens. I've got 14 oxygens on the left-hand side. 14 oxygens on the left-hand side. So I need to get 14 oxygens on the left-hand side. I have 14 oxygens on the right-hand side. I need to get 14 oxygens on the left-hand side. Okay? So what I need you to notice, it might be tempting just to put a 7 here and then say you're done, but don't forget about these oxygens right here. So if you notice, this 2 affects this oxygen, and so there's already 2 oxygens on the left-hand side. And so that means if I subtract 14 minus 2, I get 12. And so I need 12 oxygens out of this molecule right here. So what I'm going to do is change this number to a 6 so that I get 12 in total. So I get 12 oxygens plus 2 oxygens. That's going to change this to 14 oxygens. And now the oxygens are balanced. And so for my final answers, I'm going to circle them in yellow. I should have a 2 out in front, a 6 out in front, a 4 out in front, and a 6 out in front. Now, let's think about this. Hold on just a moment. The carbons are balanced. The hydrogens are balanced. And the oxygens are balanced. But do you notice that the final answers are 2, 6, 4, 6? And they all could be divided by 2. We could divide this one by 2. We could divide this one by 2. We could divide this one by 2. And we could divide this one by 2. So that we get 1, 3, 2, 3. So let me go ahead and erase all this. Give me just a moment. Go ahead and erase all this. Our original equation was C2, hold on, I have it written down actually. C2H5OH plus O2 goes to CO2 plus H2O. I wonder if I put something out here like a 3, and then I put something out here like a 2, and I put something out here like a 3. Would these yellow numbers balance the equation? Let me put them in red so they're a little bit easier to see. CHO. On the left-hand side, I have 2 carbons. On the right-hand side, I have 2 carbons. On the left-hand side, I have 6 hydrogens. On the right-hand side, I have 6 hydrogens. On the left-hand side, I have 6 oxygens plus 1, which is a total of 7 oxygens. On the right-hand side, I have 4 oxygens plus 3, which is a total of 7 oxygens. So actually, by simplifying my balanced chemical equation, I get this as my final answer.